First, we will discuss evidences for evolution, specifically fossil evidence. Fossils are preserved remains of any once living thing from the past. They are an important evidence for evolution because they show that life on Earth was once different. Scientists use fossils to gather information about the history of life. They are used to study evolutionary relationships of organisms. Fossils allow us to peek in the past and see how prehistoric organisms looked and behaved, which is vital to understanding today's organisms. Next, we will discuss speciation, specifically allopatric speciation. Speciation is defined as the formation of new and distinct species. There are 4 types of speciation: allopatric, peripatric, parapatric, and sympatric. The image depicts allopatric speciation. Allopatric speciation occurs when a population is separated geographically. When there is a geographic separation, the organisms on both sides cannot mate, so they evolve separately. Next, we will talk about the properties of water. And the property of water that we will be discussing is cohesion and adhesion. Cohesion and adhesion is a property of water that describes how water is sticky. Cohesion describes the bonding of water molecules to each other, and adhesion describes water bonding to other things. Cohesion and adhesion help hold water together within plants and helps with capillary action. Next, we talk about lipids. Lipids are organic compounds that include fats, oils, and phospholipids. They are greasy to the touch. Have you ever gotten oil on your hands and tried to wash it off with water? It doesn't work well, right? That's because lipids are insoluble in water, meaning they don't dissolve. Lipids' functions include energy storage, signaling, and they are structural components of the cell membrane. Next, we will discuss water potential. Water potential is the measure of the ability of water molecules to move freely inside of a solution. The more free water molecules there are, the higher the water potential, and vice versa. In a solution where there is no solute, all the water molecules are able to move freely. Therefore, there's a high water potential. Adding a solute lowers the water potential. Last but not least, we discuss enzymes. Enzymes act as catalysts to speed up the rate of chemical reactions by lowering the activation energy. They are vital for life and aid in digestion and metabolism. But how do enzymes work? A substrate binds to the active site of an enzyme, and it's converted into a product. Once the product unattaches from the active site and exits, the enzyme will repeat the process.